Hello everyone and welcome to our video. We are sophomore students at Al Akhawain University who conducted an engineering project through fall 2020. The project is realized by Hajar Affas, Fahd Mamoun and Zineb Boukouiss and is supervised by Dr. Yassine Saleh Al-Alaj.
In order to professionally and efficiently manage our projects, and after brainstorming, we begin by conceptualizing the design of our circuit. Since we had to completely change the project, we were forced to both brainstorm and draw the layout within 2 days only. We then placed our order and received the components that were ideally chosen within around 2 weeks. Subsequently, we built the system, checked whether it's functioning or has any defaults, and finally we had to finalize the functioning mockup. Based on the customer's needs, we were able to draw a priorities table in which we treated different criteria following whether they are primordial or just additional features. This helped us determine what were the parts or components we had to put emphasis on when designing our product. Subsequently, we had to transform our prioritized table into a flowchart called the objective tree. It puts the light on three main objectives of our power bank, being the safety, cost efficiency, and functionality. Each requirement was divided into sub-requirements that are primordial for the conception of our product. As of the engineering requirement properties, our power bank has four main properties. It is abstract, verifiable, traceable, and unambiguous. Obviously, we encountered many engineering obstacles when conceiving our product. However, we were able to put it to an end despite the constraints that can be seen in the screen. As of our marketing strategies, also referred to by steeple analysis, our product complies with numerous factors, namely the political and legal ones. Also, it is environment friendly and has positive impact in both society and economy. Moreover, it is a purely technological creation as we used only electronic components that can be easily acquirable.
We started with the goal of solving one of the 21st century challenges, specifically to the challenge of making solar energy economical.
As you can see in the morphological charts, we proposed a couple of solutions to three main components of our product, namely the solar panel A, the electronic motherboard B, and the power bank capacitor C. The following is our design solution space tree. Thanks to it, we were able to determine how many solutions we could have proposed to the conception of our product. The source of light we will use is a light bulb. Even though our prototype can perfectly work under the exhibition of sunlight, the way we will operate is that we will leave the solar panel exposed to the light bulb for a few instants. Subsequently, we will connect the solar panel to the ends of the motherboard. After a couple of minutes, what will happen is that the solar panel will transfer electrical energy to the motherboard through the connecting wires. Slightly after, if we connect our power bank with the motherboard via the USB port, we can notice that the power bank begins charging.
The following house of quality shows our application of the QFD on our project. We basically made a chart that includes all the customer specifications and the engineering technical requirements. And as you can see, the matrix shows the relationship between the two using values. So we have 9 for high correlation, medium for medium correlation we have 3, and 1 for weak correlation. The second step in the specifications part of the EDP is Kano's model. So as you can see, our expected quality is to put energy into a device's rechargeable battery. Our performance quality is if we are able to make the charging faster, and our excitement quality is if we are able to implement speakers and a flashlight. Now, concerning the concept evaluation process, we started off by making the PUG matrix. As you can see, it shows our customer requirements and it measures its importance with regards to our project and with regards to other similar power banks that are currently in the market. As you can see from our decision matrix, we weighted some of our requirements with the possible project designs, and we ended up deciding to build a normal solar bank without including flashlights and without including speakers because it was the most favorable.
When conceiving our product, we have put numerous attributes into it in order to keep up with competitors and to produce a marketable, reliable, safe, and less expensive power bank that uses solar energy. More specifically, we have taken into consideration several attributes when designing it, and to which we refer by designing for X in engineering. Those attributes are firstly, designed for manufacturing, secondly, designed for assembly, and finally, designed for environment. Design for manufacturing is the optimization of a product or component's design in order to conceive it in a cheaper and easier way. Design for assembly is a process by which products are designed with ease of assembly in mind. More specifically, if a product contains less parts, it will take less time to assemble and therefore less assembly costs, and the other way around. Design for environment refers to important rules implemented and taken into high consideration in order to reduce a product's impact on the environment and human health. For instance, when a product's useful life comes to an end, design for environment is concerned with its disassembly in order to determine its design environmental impact and associated benefit cost.
Concerning the updated cost analysis, the project was made up with a saving of 440 dirhams, where the power bank is the most expensive component in all of the materials, with 200 dirhams. Comes after polycrystalline solar panel with a price of 70 dirhams. Then in the last we find the diode, wires, and the package box with a total cost of 100 Ds, which I think is pretty reasonable for such a project.